So, tangents. So here's a line that's tangent to a circle. This is what we're probably most familiar with. If you're with me last year, then we did this maximizing the volume of a box kind of problem. Then we also talked about tangents there. So you can be tangent to a function. So that means that this line touches at P, but it doesn't cross. Okay, this is what crossing looks like. So this is not tangent. And then don't be completely surprised that you can be tangent somewhere and cross somewhere else. So yes, this is not tangent here. This is called cross or intersect. But here at P, this line is still tangent. So we're looking at a specific point for a line of tangency. So we're looking for a line that touches. Okay, that line is important when you go from Precalc to calculus, and it has something to do with limits. And the way that it works is basically it deals with the slope of the line as if when you're looking at point P and point Q. So, for example, on the first part, if I'm comparing the line, or sorry, if I'm on the line from P to Q, what would be the slope of that line? What's the definition for slope?
Y minus y, Q to y divided by Q to
Okay. And you're right in terms of your y2 minus y1 over x2 minus x1. Okay? So I'm going to abbreviate this a little bit. Okay. What's your y2? That's f of x, isn't it? And y1 is fc. It's the point that I'm interested in. And the change in x is x minus c. Well, so if you find the limit of this thing, what you're doing is the following. You're taking Q and you're moving it a little bit closer. And then you look at it one more time. And you find a new value for your tangent slope. And if you move it a little bit closer and you find the slope of the line there, then we're getting closer and closer until the point where I'm basically going to put Q right on top of P. And so now when P and Q are almost on top of each other, if you found the slope of that line, you have the slope of the tangent. Well, making something closer and closer to a point that you're interested in is called a limit. So if I just find the limit of x going to c of slope, and the expression for slope is right here, well then that should be the slope of the tangent line, which, you know, it is. So this is how this thing's or where this thing comes from. So it's not really complicated, it's just the slope, but in context of a function. So we don't really have any nice numbers right now, and you won't really see any nice numbers for a while with this, okay? Now they come out as numbers, but to evaluate it you sort of have to work with the function. If you have the slope of the tangent line, should you be able to write an equation for it? Okay, so now let's assume that we found that slope. How do you write the equation for that? Let's use blue. So how do I write the equation once I have the slope? How can I write the equation that goes through this point? If you have a slope and you have a point, what can you do with it? You guys remember this one that I asked you to use early in the year because it applies actually, not supposed to be a 1, sorry. Does that ring a bell?
Yeah.
Well, this is why we use it, because if you have the slope and you have a point, which we do, then you can write the equation. If you fill this in, if I fill this in for the general case, I get this equation over here. There's the slope. It's x minus c, because the x we're interested in is c, and here you get y minus the function's value at c. Well, that's just from the point of interest. So let's just look at a problem and see if we can make a little more sense of this. So we're going to find the equation of the tangent line to the graph of f of x is 2x squared. Okay. Now you don't have to do this, but I think it's good that you have an idea of what this picture sort of looks like. So I'm going to draw 2x squared sort of quickly. Sorry, Ja. I hate to disappoint you. It's a quadratic, right? Yes? No? It has symmetry, correct? There it is. Okay, it's just x squared, but multiply your y's by 2. So instead of being at 1, 1, I'm at 1, 2. Instead of being at 2, 4, I'm at 2, 8. So we're interested in that last point there. And so what I want to find is first of all, I want to find the slope of the line that's tangent here. So I want to find that slope. Well, I can find that slope by taking the change in y and comparing it to the change in x. Right? Once I have that slope, I should be able to write the equation for it because I know that this point is on the line and I have a slope. So just fill in your point slope formula and you're on, and you should be able to finish the problem. So let's see if we can identify some things here. So the x I'm interested in is 1, and the function value at 1 is 2. Okay. And so we are trying to find the tangent line's slope, and on the previous slide we talked about the fact then that we're supposed to do this. At 1, take the function, subtract the y value at 1, compare it to x minus 1 in this case. You guys okay with me filling that in from what I have here, f of x minus f of c? Okay, that's where that comes from. Alright, what is the equation for the function? The function is what? F of x is 2x squared, and f1 is worth 2. Okay, can I find this limit right now? Not yet. Why not? What happens if I plug in a 1? You plug in a 1, you get a undefined, right? That means this thing is factorable, which they always are. Take out the 2 first. That'll make it a little bit easier to see the full factorization. So after you take the 2 out, the top factors to 2 times, and x squared minus 1 is actually... Okay. Thank you. Now what can you do with the x minus 1? Cancel. And can you find the limit now? As x goes to 1, you end up with 4. So this slope here is 4. Alright, well, can you write the equation for this line then? What else do you know about this line? You know the slope now. What else do you know about the line? What point is definitely on that line? 1, 2. Oh, I drew it at the wrong point, didn't I? Oops. I drew it at 2. This is supposed to be at 1. I can fix that. I need to fix that. That's sort of bad. Slope is still the same value, but we know that the point is 1, 2. So I should have been here. So there's the tangent line. That's your slope, delta y over delta x, which was 4. The point 1, 2 is on it. So what does that mean? You can do y minus 2 is your slope, which is 4 times x minus 1. There's the equation for the tangent line at 1. Do you think it would be the same as if I was at 2? You think I get the same equation if I was at 2?
Yeah.
You think so? Same slope? That's sort of what makes a curve a curve, right? The slope can change. What do you think is happening at 2 to your slope? Do you think it's larger or smaller? Larger. So the function increases faster and faster and faster, right? Okay, so yes, that's true. Alright, okay. Because that concept is so important in math, they gave this its own special name. It's called the derivative. Because it's so special and it has its own special name, it has its own special symbol. It's called f prime of c. So, I lost my marker. This thing over here, this is short for saying the slope of the tangent line of the function f at x is c, at c. Mathematicians are notoriously lazy, so instead of writing that whole sentence, we just call it f prime. And we have a set definition that goes with it, and this is just what we just did a moment ago. So we're going to do this one more time at a specific point for a specific function. And then we're going to make this into a little bit more algebra, and we'll do it at a non-specific point. So how do you do this? Well, I think it helps if you just can find out what f of 1 is. So what's f of 1 worth? So how much, what did you say?
2.
Yeah, you're way ahead of me. But yes, it's 2. You get 3 plus 1 is 4 minus 2 is 2. Okay? Then we're going to find f prime of 1. So that means the limit of x going to 1 of the function. You don't necessarily have to write this step here. Minus f of c divided by x minus c. So I'm going to fill in the parts that we know, which are what? What's the function? F of x is actually minus 2x plus 1, right? Fc, which is actually a 1. F of 1 is worth 2. And c is worth 1. So you get this. Well, we can clean that up a little bit in the top. So this ends up being 3x squared minus 2x minus 1 divided by x minus 1. Okay. Now here's sort of the nice thing. Even if you're not great at factoring, for this limit, for you to be able to work with this, you know that the top has to be factorable. And not only is it factorable, if you do this right, what factor has to be one of the factors in the top? The bottom one. So this is my best guess for the first factor. Well, and then we're just going to work backwards a little bit. If that's supposed to be a 3x squared and that says x, then this better be a 3x, right? Yes?
Yes.
Alright. And if this last number is a negative 1 and I got a negative 1 here, then I better make this a positive 1, right? Because a negative 1 times a positive 1 is a negative 1. Yeah? There's your cancellation. So we're actually just trying to find the limit of this thing. And that limit is indeed 4. You just plug in the 1. 3 times 1 plus 1 is 4. So what does this represent? The slope of the tangent line, right? At what point? At x is 1. Right? Yes? Okay. Can I move on? Alright. Let's make this a little trickier. So I'm going to start sort of the same way. So what is f of c? Well, it just says x cubed, so c cubed must be c cubed. Are we okay with that? Okay, so we're going to find the derivative at c. That would be finding the limit of x going to c. The function, I'll fill in the function in this one right away, minus f of c, that's c cubed, divided by x minus c. So does everybody sort of see where all this came from? So instead of having a 1 now, we're just using the letter c. So what I'm doing here is actually I'm going to come up with this little equation, this function, that I can just plug in a value and it will tell me what the slope is at that point. So I don't have to keep doing the thing that I did over here, because, you know, what if I was sort of mean and I said, well, that's interesting at 1, what is it at 2? What is it at 3? And what is it actually on all integers between 1 and 100? Do you really want to do this over and over and over? So no. So we can do this easier. So what do you know about the top and the bottom? What has to happen here? For this to work, what has to happen here? It's factorable, right? And x minus c must be then a factor both in the top and in the bottom. Okay, so this is a cube. So this is a pattern. What's the rest of the pattern? xc, x times c. It used to be like a number there, right? You would have ab here if it was with a's and b's, plus c squared. X minus c cancels. What do you end up with? X squared plus xc plus c squared. What is x going to be replaced with? If this, right, with c. If this was a 1, I would be plugging in a 1 and a 1. So here I just plug in c. So this is actually c squared plus c times c plus c squared. Well, that's c squared plus c squared plus c squared. I can simplify that. That is actually 3c squared. So now if I ask you the question sort of on the right, well, let's see what happens here. What is the tangent worth at, what's the slope of the tangent at 5? What can you do? Yeah, just plug it in here and that gives you 75. What is it worth at a negative 5? Still 75. Does that make sense? Yes, in terms of the function that we started with? We started with a cubic, right?
Yep.
Here's the picture of a cubic. Cubics look like this, right? My curve on the left is a little off, or on the right. Yes? So the tangent line here is clearly positive, right? That would be a positive 5. What happens at a negative 5? Is your tangent still positive? Yeah. So it does make sense. In the previous class, they were sort of surprised that at a negative 5, the tangent was still positive. You good, John? Okay.